ever found yourself stuck in traffic, looked up at the sky, and just wished you could, fly away? What if that wasn't just a daydream? And what if that same vehicle that lets you hop across the city could one day take you all the way into orbit? It sounds like pure science fiction, I know. But we're about to walk through a business case that lays out a surprisingly practical step-by-step path to make it happen. Let's get into it.
So, here's our game plan. We're going to start with a problem we all know way too well: getting around our crowded cities. Then, we'll introduce a pretty radical vehicle design that tackles this. After that, we dive into the heart of it all, a brilliant three-phase master plan. We'll peek under the hood at the tech that makes it all tick, and then we'll tie it all together to see how the road to space might actually start right in your own driveway.
All right, first things first. Before we even think about touching the vacuum of space, we gotta start right here on Earth. Or, to be more accurate, just a few hundred feet above it. The very first piece of this whole puzzle is about solving a headache we can all relate to: urban travel.
I mean, think about it. Every single day, we're dealing with gridlock, with congestion, with infrastructure that's just bursting at the seams. So the real question isn't just if we can do better, it's how. And the answer might literally be to look up.
Okay, so on the left, that's our world today. We're stuck on roads, limited by traffic. But over on the right, you see a technology that could change everything. VTOL, which stands for vertical takeoff and landing. It's kind of like getting the best of both worlds. It can lift off and land like a helicopter, but fly forward efficiently like a plane. For this emerging urban air mobility market, this is an absolute game changer. It means you can just bypass the traffic jam entirely.
So VTOL is the how. Then what's the what? What's the right vehicle for the job? This is where the plan gets really interesting, and frankly, a little weird, but in a totally brilliant way. It's time to meet the prototype.
And that perfect shape is a sphere. Yep, a sphere. Now, I know what you're probably thinking, because I thought it too. A giant ball doesn't exactly scream aerodynamic. But stick with me here, because for the messy, optical-filled reality of a city, it might just be the smartest and safest shape you could possibly imagine.
See, this isn't about style. It's all about function. That spherical shell acts like a protective cage. It means the vehicle can literally bump into things without damaging the important bits, the propellers, which are tucked safely inside. And because they're encased, it's way safer to be around people. Get this, it can even land on a rocky, uneven slope and just roll into a stable position. This isn't just theory either. We're already seeing this concept work in drones built for tough spots like disaster zones.
And this quote right here, this is the grand vision, the Sevco sphere. The whole idea is to start with this super practical, safe urban vehicle, but to build it from the very beginning to evolve into what they call a space airstream. Just picture that, a personal, customizable RV for taking the family on a vacation to orbit.
Okay, so that's the big question, right? How in the world do you get from a city-hopping air taxi to a space airstream? This is where the business case really shines. It's not one giant risky leap. It's a super pragmatic three-phase plan that builds on itself every step of the way.
The whole strategy just unfolds in these three really logical stages. First, you establish the market and actually start making money. Then, you use that success to build a truly independent, autonomous vehicle. And only then do you shoot for the final frontier: interplanetary travel. It's a clear, smart roadmap from a business that works today to a vision that will change tomorrow.
Phase 1 is all about proving people actually want this. And the genius part is, they don't start by trying to invent a whole new rocket from scratch. Nope, the plan is to build the sphere as a habitat first, a kind of luxury space RV, and then partner with companies that already exist, like SpaceX, to just ferry it up to orbit. This proves the market for space tourism, it brings in revenue early, and it gets the product out there.
So once the market's proven and the money is flowing, Phase 2 is all about cutting the cord. This is where the sphere gets its own wings, so to speak. It evolves to have its own independent takeoff, its own flight systems, and its own re-entry capabilities. No more relying on third-party rockets. The vehicle becomes a truly personal, reusable spacecraft, which is what really opens the door for regular, more affordable space trips.
And finally, we get to Phase 3. This is the big one. This is the grand vision. With a fully autonomous vehicle, the focus shifts to adding in deep space propulsion. This is what turns a trip to orbit into a multi-planetary tour. We're talking Mars flybys, exploring the solar system, pushing the sphere into the realm of true human exploration.
Okay, an ambitious plan like that needs some seriously powerful technology to back it up. So is this all just wishful thinking, or is the engineering actually credible? Let's pop the hood and look at the 3 key innovations that could make this whole thing work. First up is something called silent lift. This is the magic that makes that initial urban vehicle a reality. It's a whole system of spread out, encased electric fans. This makes the craft incredibly safe, but also quiet enough that you could theoretically take off from your driveway without having all your neighbors hate you. This is the foundational tech that makes the entire business plan work from day one.
Next is the Aura Drive. This is the tech that unlocks Phase 2. It's an advanced type of rocket engine called an aerospike. So you know how regular rockets have that big bell shape at the bottom? That shape is only super efficient at one specific altitude. An aerospike, though, cleverly uses the air pressure around it to basically form a virtual nozzle that stays efficient all the way from the ground up into the vacuum of space. It's what lets the sphere become its own rocket ship.
And what holds it all together? The Hydra hull. This thing is amazing. It's made using massive water pressure to literally bulge a metal structure into a near-perfect sphere. The process makes it incredibly strong, but also ridiculously light. We're talking over 90% lighter than if it were made of steel. That combo of strength and low weight is crucial for everything from city flying to deep space cruising.
All right, so we've got the urban problem, we've got the spherical solution, we've got the 3-phase business plan, and the core tech. Let's put all those pieces together now and see how this very practical plan could lead to a pretty incredible future.
This engineering roadmap just ties it all together beautifully. You can really see the step-by-step logic. They're not jumping straight to Mars. They start small, building and testing drone-sized prototypes to perfect the flight software for flying around cities. Then they scale up, testing the full-size hull and life support with high-altitude balloons. After that, they plug in that powerful Aura drive for orbital tests. And only after all of that is checked off do they move to the final step, getting it certified for you and me to fly in.
You know, this whole business case leaves you with a really fascinating thought. It suggests that our path to becoming a truly spacefaring species doesn't have to be some single monumental government project. Instead, it could be a commercial journey, built piece by piece, starting with a clever solution to an everyday problem. It makes you wonder, what if the road to the stars is actually paved right through the middle of our own cities?